This is the third in a series of videos highlighting the deployment of a Falmouth Scientific two-dimensional acoustic current meter in Buzzards Bay in Massachusetts near the west end of the Cape Cod Canal. In the previous video we described the deployment and how we configured and deployed the instrument using FSI's ACM Pro software. Here we're going to use the same software to offload the memory of the instrument after the deployment and save the data file for further analysis. So we're going to go to Retrieve Data. The software queries the instrument. You can see here it's prompting us for a file name on our hard disk, and we can put it anywhere we wish on the hard drive, and it also tells you how many scans are currently in the memory. So we're going to call the file FSI 2D ACM and click on Download. Here it gives us the ability to put in unique identifying information that would be stored in the header of the data file. Deployment number, mooring, latitude and longitude, or depth of deployment. For this exercise I will leave those blank. And so now the download begins through our serial port, and it gives you an update as to the scans being read. Because this is going to take about 20 minutes, I'm going to skip ahead, show you what the data file looks like, and then we will do some post-processing and data analysis. Okay, we've successfully offloaded the data. This is what the data file looks like. This is the header where all that unique identifying information would be if we wanted to put that in there. You can see time and date were recorded, conductivity in millisiemens per centimeter, temperature in degrees C, pressure in decibars, salinity in PSU, sound velocity in meter per second. We have heading information from the compass, tilt, X and Y axes, and velocities both north and east in centimeters per second. What we're going to do, this is a standard, this is a .dat extension, which is comma separated variable, which can be opened in Excel as well. So now we're going to open this file in our post-processing software called ACM Post, which will allow us to graph the different variables and for analysis. So we've opened the data file in ACM Post, and you can see up here on the left you have several different programmed graphs that you can select. This one is velocity over time. You can see that you have both the north and east velocities plotted here, and you can see how and again the scale is in centimeters per second, and you can see how the velocity changes with the tidal influence. So that's velocity over time. You can also get a stick plot of speed and direction. Again, you can see that the length of the line indicates the velocity, and the direction is you can see north is up, and you can see that the velocity of the outgoing tide is much stronger than the incoming tide, and we can show you again where the instrument was deployed, so you can kind of get a feel for that after we go through the rest of these graphs. But a very graphic indication of the velocities and directions. The progressive vector is, again, it's a compass rose, so this is due north up top here, and you can see that the velocities of the outgoing tide into Buzzards Bay is much stronger than going into Buzzards Bay, going towards Cape Cod Bay from Buzzards Bay up through the canal. Because of the location of the instrument and the Massachusetts Maritime Academy, it's possible that influences the velocities coming in. Although further analysis will be done to determine why this is. Distribution, again, you can see this is just the percentage of scans at the speed. Here's the speed in centimeters per second, and the direction. That's interesting information. And this is the data from the CTD, the conductivity, temperature, and depth sensors that are on there. The blue indicates the pressure changes. These little anomalies in here might be seiches in actually going by during the tidal changes. You can see that the green plot is temperature, the red is conductivity and the yellow is salinity. And you can see here that as the tide is going out, the temperature goes down. The temperature in the we all know that the temperature of the water in Cape Cod Bay is much cooler than in Buzzards Bay. So this definitely corroborates that information. As the tide is going out, the current is flowing from Cape Cod Bay to Buzzards Bay, and you can see the dramatic change in temperature. And again, when the tide changes and the current switches direction, you can see that the temperature goes up because the water is coming from Buzzards Bay. So very interesting information. What I also did, just to summarize, is if we look at this is the deployment. Again, we're back at the deployment picture from Google Earth. Here's the ship. Here's Mass Maritime Academy. Here's the Cape Cod Bay, and I've overlaid the progressive vector graph here to show approximately where the instrument was located and the difference in velocities and direction with tidal change. I hope that you find this information interesting, and for more information on Falmouth Scientific products, please visit our website at falmouth.com. Thank you.